Okay, I'm just going to run through some questions from Unit 1 so you can look at them before your exam. So first, we're dealing with some radicals. The root of 6 times 3 times 18, that's like all of these things are in brackets here. So 6 times 3 is 18, and 18 times 18 is the same as 18 squared, right? So if we're taking the root of 18 squared, that's going to be 18 again. We could multiply 6 times 3 times 18 and say that's the root of 324 and punch it into our calculator, but we would still get 18. For B, the root of, and then this whole big mess in here. So on the top we have root 81. The root of 81 is 9. 9 times 9 is 81. And the root of 49, square root of 49, is 7. And on the bottom, we have 196. The square root of 196 is 14. And root 100, the square root of 100 is 10. So we have to take the root of all of this, which means we first need to add up the top. 9 and 7 is 16. On the bottom, 14 minus 10 is 4. 16 over 4 is 4. Remember, we're still taking root of all this. And the square root of 4, I'm just going to rewrite it over here, is, well, 2 times 2, so it's 2. So that's our answer there, that's our answer there. For question 2, which number, this one or that one, is greater? So the first one we can try root 25, which is 5, plus root 144, which is 12. 5 plus 12 is 17. So that's this one. And for the second one, if we do 25 plus 144, which is 169, and then we take the root, the square root of 169 is 13. So explain your reasoning. You don't need to write it out. You just need to say that these ones equal 17 and these ones equal 13. So if it's together under the root, first we add it, then we take the root. But if the plus sign is not inside of the square root, we resolve this one first and resolve that one second and then add them together. So that one's the bigger one there. Oops. Wanted to do highlighter. There we go. That's the bigger one. Next, is each expression a monomial, binomial, or trinomial? So we have monomials, binomials, and trinomials. Trinomials have 3 terms like this. Here's our third term. The binomial, this is our second term, second term, second term. And for monomials, this is our first. So we give the greatest number, right? So this one has 1, 2 terms, so it is a binomial. This one has 1, 2, 3, it is a trinomial. This one has 1, it is a monomial. This one has 2, it is a binomial. The dividing line is those operators, minus or plus. So 1, 2 divisions makes 3 things, or 1 division makes 2 things. No divisions, there's just 1 piece. For number 4, identify the degree of each polynomial. 7t plus 4, the highest degree is here. This is t to the 1. So this degree is 1. Here, this degree p squared, that's a degree of 2. Here's p, that's a degree of 1. Here's just 7, that's a degree of 0. So the highest degree is 2. So we look at each term, say what's the degree, what's the degree, what's the degree, and we pick the highest one. Here, this could be 4x to the 0, or it could be 4y to the 0, it could be 4z to the 0. It doesn't matter, it's to the 0. So the degree of this polynomial is 0. Any constant, 0. 11q squared, the degree of q is 2, so this degree is 2. Next, evaluate these expressions. 5 times 5 to the 4th, 5 times 5 times 5 times 5 times 5, that's 5 to the 5th, oops, that's 4 plus 1, which is 5, and 3 times 3 times 3 times 3, that's 3 to the, we could say 1 plus 3 or 3 plus 1, but anyway, there's going to be 4 of them. 5 to the 4th is 625. 3 to the 4th is 81. And if we subtract them, we get 544. For B, 3 plus 4, squared minus 2 minus 4 cubed. First, we need to do what's inside this bracket and what's inside this bracket. Then we need to do the exponent, and then finally we need to do the subtraction in the middle. So first, 3 plus 4 is 7. That still needs to get squared. 7 squared is 49. And over here, 2 minus 4 is negative 2 cubed. Still minusing in the middle here. And negative 2 cubed is negative 8. And at the end here, 49 minus negative 8 is the same as 49 plus 8, which is 57. Next, 5 cubed minus 4 squared to the 0. This is all to the 0, so this whole term is just worth 1. Everything that's inside this bracket, I don't care what's inside that bracket because it's to the power of 0. It's worth 1. And in this bracket, we have 6 squared, which is 36. So this 6 squared is this 36. And we have 8 to the power of 0, and 8 to the power of 0 is just 1. So 36 minus 1 is 35. And 1 minus 35 is going to be negative 34. That's our answer there. So negative 34. For D, we got a bracket with an exponent on the outside. Inside the bracket is what we need to do first. So first we need to do 12 divided by negative 2. 12 divided by negative 2 is negative 6. Oops. Negative 6 still has to get cubed, and that's 6 squared minus that. If we cube negative 6, that's negative 6 times negative 6 times negative 6. That's negative 216. So 6 squared minus negative 216. Let's continue up here. 6 squared is 36. If we're subtracting 36 minus negative 216, that's the same as like adding 216, which is 252. Next, we've got 7 squared plus 2 squared plus times 7 squared times 2 squared times 7 cubed times 2 to the power of 1 times 7 to the 0 over 7 squared times 2 to the 0 times 7 squared times 2 squared times 2 to the 1. Let's collect all of our 2's and our 7's. Keep the ones with the same bases, right? That's a 7 base, 7 base, 7 base, 7 base, 7 base. There's all our 1's in 7. And for all the 1's in 7, we've got 7 to the power of 2 plus 1 plus 3 plus 0 on top. And on the bottom, I didn't give myself enough room, but it's 7 to the power of 2 minus 2. So just for the 7's, on the top we have 2 and 1 is 3, and 3 is 6, and 0 is nothing. And on the bottom, 2 minus 2 is nothing. So 7 to the power of 0, just like anything to the power of 0, is 1. And for our 2's, we got 2 cubed squared to the power of 1, a 0, a 2, and a 1. So on the top, we've got 2 to the power of 3 plus 2 plus 1. I guess I should do that up here. And on the bottom, we have 2 to the power of 0 and 2 and 1. So on the top, 3 and 2 is 5 and 1 is 6. On the bottom, we have 0 and 2 is 2 and 1 is 3. When we're dividing with the same base, we're subtracting. So this is 2 to the power of 6 minus 3. 6 minus 3, 6 minus 3 is just 3. And our 7 we've already figured all out. It's just 7 to the 6th. So that's our final answer there. We could say 7 to the 6th is whatever, some giant number times 2 cubed. 2 cubed is 8. We get some other giant number. So if you get a number like 941192, that's good too. Or you could leave it like this. Next, 5 cubed times 2 plus 4 squared times 6 times negative 9 to the 0 over negative 4 to the 0 times 6 cubed times 7 minus 2 squared. We've got a whole bunch of things we need to prioritize. First step is going to be resolving that bracket and that bracket. So this first bracket's going to work out to 6. The second bracket's going to work out to 5. Just do it like this. That's a 6. That's a 5. Then we can find things that have the same base. That doesn't look like there's going to be a lot of them. There's going to be a 5 cubed over here. Maybe I'll highlight. There's going to be a 5 cubed over here, and this is going to work out to 5 squared on the bottom. So for the 5s, we have a 5 cubed on top and a 5 squared on the bottom. 3 minus 2 is 1. So we're going to work out to 5 to the power of 1. For 6s, we've got 6 squared on the top, 6 times, well, this negative 9 to the power of 0 is really just 1, right? So this is 6 times 1, which is 6 to the power of 1. So on the top, we've got 6 squared and another 6. And on the bottom, we have 6 cubed. So on the top, 2 plus 1 is 3. And 6 cubed over 6 cubed, well, that cancels out entirely, doesn't it? So all the 6s are gone. So we're done with you, we're done with you, we're done with you, we're done with the 5s as well. And all that's left is this little negative 4 to the 0 on the bottom. 4 to the 0 is 1. That's this part is 1. And it's the negative sign is not part of the base, so it still stays. So this is 5 over negative 1, which we can just write as negative 5. That could be our answer. And I know we're over 12 minutes here. This is a little bit too long, but we'll finish off the page. Here we're going to play the same kind of game. We're going to look at these 10s, a bunch of things with the same base, and we're going to look at the 5s, and we're going to look at the 2s. So we'll start with the 10s. So we have 10 squared to the power of 4. That's 10 to the power of 2 times 4, which is 8. Over here, that's 10 to the power of 5 times 3, which is 15. So that's that one taken care of, that one taken care of. On the bottom, over here, we've got 10 to the power of 2 times 5, which is 10. And over here, we've got 10 to the power of 2 times 2, which is 4. So for the 10s, on top, we have 8 plus 15. And 8 plus 15 is 23. So that's, I'll just write maybe over here 10 to the power of 23 on top. And on the bottom, we have 10 to the power of 10 plus 4, which is 14. And if we do 23 minus 14, 23 minus 14, because we're dividing them, same base, that's 10 to the power of 9. So we've got all of the 10s taken care of. We don't need to think about them anymore. Now, let's look at the 5s. So we have 5 to the 3 times 4, which is 12. On the top, there's only 1. And on the bottom, we have 5 to the 4 times 2, which is 8. And 5 to the 12 over 5 to the 8 is 5 to the 12 minus 8, which is 5 to the 4th. 12 minus 8 is 4. So now we've got the 5s done. And last, the 2s. So we have on the top 2 to the 4 times 3, which is 2 to the 12. And on the bottom, we have 2 to the 2 times 4, which is 8. And again, 12 minus 8 is 4. So 12 minus 8, we're dividing, it's 2 to the 4. So this is simplified. We could multiply it out. 10 to the 9 is 1 with 9 zeros. 5 to the 4 is some other giant number. 2 to the 4 is another giant number. We would get well, 1 times 10 to the 13 is our answer. 1 with 13 zeros after it. This is 10 trillion. 1 trillion is 10 to the 12th, so this is 10 times bigger than that. But you can leave it like this. This is simplified enough for us right now. And our last one here, we've got 2 to the 4th times 2 squared squared. We can do this two ways. Either we can multiply these two together. This is 2 to the 4th times 2 squared. This is 2 to the 4 plus 2. That's 2 to the 6, and that all still has to get squared. So 2 to the 6 squared is the same as 2 to the 6 times 2, or 2 to the 12th. So our answer should be 2 to the 12th. The other way we can do this is to take that 2 and distribute it to the inside. So let's do it another way. So that's 2 to the 4 times 2 times 2 to the 2 times 2. That's 2 to the 8 times 2 to the 4, which is 2 to the 8 plus 4, which is still 2 to the 12. So we get the same answer either way. Okay, this was much longer than I wanted this page to be, but that's how long it took.